What's up, guys? Welcome back to my channel. So today we are going to talk about stress strain curve. So in engineering material world, especially when we talk about metal, in particular steel, we are going to talk about its stress and strain curve. So this is the typical stress strain curve for steel. And the x-axis is strain and the y-axis is stress. So in this curve, we have the elastic region, and the rest of it is called the plastic region. So in the elastic region, the steel is actually acting like a spring. So which means if you add the load on the spring within the spring limits, so once you release the load, the spring can come back. So yes, you're right. It's going to be the same for the hard steel. And we call it as elastic region. So once you release the load, the steel can come back to their original length. And after the elastic region, we call it as a plastic region. So still like a spring, if you are applying too much load that goes over the spring limits, then when you release the load, the spring will not be able to come back to their original length. And the same thing for steel. So if the load goes over certain limit, then the steel is going to be slightly longer and won't be able to go back to their original length. And the point in between, which is between the elastic and the plastic region, is called yield point. And the strength of the material at that point is called yield strength. So after the yield point, if you keep applying the load, the material will not be able to come back to their original length. And another important point is called ultimate strength, or called ultimate point, or called tensile point. Ultimate point is the maximum stress that the material can take before fracture. So let's come back to the elastic region first. So in the elastic region, the strain and the stress is proportional. And the ratio, which is the stress over strain, and in math, we call it rise over run, which is the slope of the curve. And in material, we call it stress over strain, which is Young's modulus. So the stress and the strain are proportional in the elastic region. After we passed yield point, the stress and the strain is no longer proportional. And in the region between yield point and the tensile point, we call it as a strain hardening area. Strain hardening means when the load is keep applying, the material itself is getting stronger. We also call this as work hardening or strain hardening. They are the same definition, means the strength of the material is improved and the material itself is getting stronger. So in the strain hardening area, the material's strength is improved a lot, but the cross-sectional area of the material does not shrink a lot. Then when you pass the ultimate point, the necking begins. So in this region, the material is still getting strengthened. So the strength of material keeps improving, but at the same time, because of the necking, so the cross-sectional area of the material start to decrease a lot. All right, let's come back to the yield point. So we know, so yield point is the transition between the elastic region and the plastic region. Then the question is, where is exactly the yield point? So it's not here, not here, not here. Is that here? Or maybe here or here? And apparently it's not here. So we don't know where exactly that is because it's a conjunction point between two regions. So in engineering world, in order to define where the yield point exactly is, we made a 0.2% offset strain. Basically, we are going to move the elastic region line with 0.2% to the right. So whatever strain that you have, you just add another 0.002 afterwards. So the line is shift to the right. So by doing this, it's going to be an intersection point, and we call this point as yield point instead of here as the theoretical value. So this is the 0.2% offset strain. All right, this is all we have for stress strain curve. Thanks for watching. See you next time. Bye.